Hey there, SPM Chemistry students. Welcome to this explainer, where we're going to break down one of the most important topics for your exam, the elements of period 3.
But hey, before we jump in, I've got a super important tip for you. Knowing this stuff is great, but applying it under exam pressure, that's a whole different game. So you can test yourself with thousands of questions over at MCQ SPM. Just scan this code. Trust me, active recall is the best way to get ready for your exam.
So, here's our game plan for today. We're going to start with why this topic matters, then we'll do a quick atom refresher, break down all the important trends in oxides, and then, this is the fun part, we'll tackle a real exam question together before I give you the ultimate cheat sheet for your revision.
Okay, let's get right into it. Why are we so focused on period 3? Well, it's simple. The patterns here show up all the time in paper 1 and paper 2. If you can master this, you're pretty much guaranteed to grab some easy marks.
These right here are our 8 key players. And this isn't just a random list, you know. Notice how we move from left to right? We start with the metals like sodium, hit the metalloid silicon in the middle, and then move over to the nonmetals like chlorine. This transition is everything.
Now, to really understand the trends we're about to see, we've got to quickly look inside the atom. If you get the why, I promise you, remembering the what during the exam will be a piece of cake.
It all comes down to these 2 golden rules. The number of protons is like the atom's ID card. It tells you exactly which element it is. And the fact that they all have 3 electron shells, well, that's what puts them all in the same row. Period 3. Simple as that.
Right, pay close attention now. This section, this is where the marks are. We're going to decode the 2 most important trends that you absolutely positively have to know.
First up, and this one is a classic that sometimes messes with students' heads. As you move from left to right across period 3, the atoms don't get bigger, they actually get smaller.
And look at this graph. It makes the trend so obvious. You can literally see that huge drop in size as we go from sodium all the way down to chlorine. The data speaks for itself. Okay, so you're probably thinking, hang on a second. We're adding more protons and electrons. Shouldn't the atom get bigger? And you know what? That's the classic trap question that catches so many students out.
Here's the secret. As we go across the period, we're stuffing more and more protons into the nucleus. Think of the nucleus like a magnet. More protons mean a way stronger magnet. And here's the key thing students forget. The new electrons are going into the same outer shell. So that stronger nuclear magnet just pulls all those electron shells in tighter and tighter, shrinking the whole atom.
Now, the second big trend follows on perfectly from what we just talked about, electronegativity, which is really just a fancy term for how well an atom can attract electrons. It increases as we go across the period. And here's why, straight from a past paper explanation. It makes perfect sense, right? Since that nuclear magnet is getting stronger as we move to the right, it not only pulls its own electrons closer, but it's also much better at grabbing electrons from other atoms. Stronger pull equals higher electronegativity.
All right, let's move on to the properties of their oxides. I'm telling you now, you are going to get a question on this. It's pretty much a guarantee, so let's make sure you're ready for it.
Now this table, this is your master key. It summarizes the entire pattern beautifully. On the left, you've got your metal oxides, and they're basic. They react with acids. Then, way over on the right, you have the non-metal oxides, which are acidic. They react with alkalis. And sitting right there in the middle, you've got our special one, aluminum oxide. It's amphoteric, which means it plays both sides. It reacts with both acids and alkalis.
Okay, so the theory is great, but can you use it when the pressure is on? Let's apply everything we've just learned to a real-deal SPM question from 2014. So here's the question. They tell us the oxide of some mystery element X reacts with both an acid, nitric acid, and an alkali, sodium hydroxide. The question is, what is element X?
Here's how you break it down in the exam hall, nice and calm. Step 1, you spot the keywords, reacts with both acid and alkali. Step 2, your brain should immediately scream amphoteric oxide. Step 3, you scan your period 3 knowledge. Which one is amphoteric? Oh yeah, aluminium oxide. Which means step 4, element X has to be aluminium. Done.
Phew, we've covered a lot. But don't worry, I'm going to wrap it all up into one perfect bite-sized summary for you. This is everything you need for that last-minute revision.
Okay, get your phone out and screenshot this slide right now. Seriously, this is the entire topic on one screen. You've got the change from metal to nonmetal, the size decreasing, electronegativity increasing, and the oxides going from basic to acidic. It's all there.
So, you've got the concepts down, you've got your cheat sheet. So, are we done? Well, not quite. The real question is, are you truly 100% exam ready?
All right, the final and most crucial step is practice. Turning this knowledge into actual marks is what it's all about. The best thing you can do is to test yourself right now while it's fresh in your mind. Scan this code one more time, hop over to MCQ SPM, and smash those period 3 questions. Go prove to yourself that you've got this mastered. Good luck!